So today our topic of discussion is vector in 3D. Okay. So with questions, we'll cover the theory also simultaneously. Let us see the first question. So you see this term non-collinear vectors at many places. Okay. So what is meant by collinear vectors? Collinear points we all know. If 3 points are collinear, they must lie on a straight line. No? Then only we say 3 points are collinear. Now what do you mean by 2 vectors are collinear? Collinearity of points is for 3 points, because 2 points there is no point of discussing collinearity, because 2 points will be always collinear. They can exist on a line. Okay. But when it comes to vectors, you can talk about collinearity between 2 vectors also. That is, if A bar comma B bar are collinear, then A bar is equals to lambda times B bar. Okay. So if 2 vectors are geometrically, what does it mean? If you have some number of vectors like this, some are larger, some are shorter, some are opposite direction also, different length. All these vectors, we call them as collinear. Okay. Now, here the important point in collinearity, what is important is, for example, if A bar and B bar are non-collinear and some x1 times A bar plus x2 times B bar is equals to y1 times A bar plus y2 times B bar, then x1 must be equals to y1 and x2 must be equals to y2. Okay. What does it mean? Means, what is this called? There is a term for this. This is called linear combination. Linear combination of A bar and B bar. Okay. So if you make a linear combination of A bar and B bar, that means 2A bar plus 5B bar, that is one linear combination of A bar and B bar. 3A bar minus 7B bar, that is one linear combination of A bar and B bar. So if you make one linear combination, okay, of A bar and B bar, and if you make another linear combination of A bar and B bar, 2 linear combinations we have made. Okay. So if provided A bar and B bar are non-collinear, that means A bar and B bar are in different direction. Okay. Then different combination will give you different vectors. No 2 combinations will give the same vector. No, not possible. That is what they are saying. That means if 2 different combinations, that is, here the combination is x1 x2, here the combination is y1 y2. If 2 different combinations are giving the same vector, that is overall vector, it means those 2 are not 2 different combinations, they must be the same combination. That's why x1 must be equals to y1 and x2 must be equals to y2. That is a condition. Okay. When the combination you are taking for non-collinear vectors, if you're taking combination of non-collinear vectors, then only this thing will hold true. Okay. Now let us see here. A bar and B bar are non-collinear, they are saying. Okay. Then find the value of x for which the vectors, these 2 vectors are collinear. Which 2 vectors are collinear? Alpha bar and beta bar. Okay. If 2 vectors are collinear, then already we have seen, if they are collinear like this, alpha bar must be equals to lambda times beta bar. Okay. So if I continue the solution, that is alpha bar is x minus 2 times A bar plus B bar must be equals to lambda times beta bar. That is, this if you multiply with lambda, 3 plus 2x times lambda A bar minus 2 lambda B bar. Now you see, A bar and B bar are non-collinear. So both sides there is a linear combination of them. If those 2 are same, then the coefficients also you must equate. That is, x minus 2 must be equals to 3 plus 2x into lambda, and 1 must be equals to coefficient of B bar must be equals to minus 2 lambda. So lambda is how much here? Minus 1 by 2. That you substitute it here, you will get the value of x. Okay. Next. Now the complete question I will answer slowly. But just what does this mean like this? Whenever, say, I just want to, everyone know the line equation, right? R bar is equals to A bar plus lambda B bar. This is called vector equation of line. Okay. Now, in this different terminology, we should understand. Okay. What is A bar? What is B bar? What is R bar? Okay. First thing, because I have seen that many students have this misconception of R bar and all in this equation. Okay, let me try to explain. See, this is your line L. Okay, both sides it is extending no, to infinity. Somewhere in this plane, origin must be there. It may not be on the line. Let's say origin is somewhere here. Now, what is A bar? A bar is position vector of a point on the line. So if you take any point on the line, one point on the line, the position vector of that point, that is only A bar. Okay. So A bar will not be on the line or anything like that. No, A bar is just the position vector of a point on the line. What is B bar? B bar is a vector parallel to the line. Okay, this I think is clear only for everyone. Okay, so vector parallel to the line means B bar will be something like this. Okay, now if I want to write vectors which are parallel to B bar, they will be 2B bar or minus B bar. All these vectors are parallel to B bar or not? 3B bar. Okay, or in general, I can say lambda times B bar will be a vector which will be parallel or anti-parallel. They will be collinear with B bar. Okay, now at A bar, if I start and if I move on the line, and this vector will be, since this vector, violet color vector, is it on the line or not? Yes, it is on the line means then it must be parallel to B bar. So lambda times B bar something it will be. You will reach some point now. That point is P. Okay. Now, if I ask you, what is the position vector of the point P? Use the triangular law of addition. You will get A bar plus lambda times B bar. Agreed? So what is A bar plus lambda B bar? A bar plus, if you change lambda, then you will get different points on the line. So what is A bar plus lambda B bar? Understanding it is very important. That is R bar, that is position vector of, this R bar is position vector of any general point on the line. So for example, if I take this line equation, R bar is equals to, like this I have written now. So if I simplify it, 1 plus 2 lambda times I cap plus minus 1 minus 3 lambda times j cap plus minus 10 plus 8 lambda times k cap. Now, what is this vector? This vector is the position vector of any general point on this line. That means that if this is origin, then the coordinates of this point will be 1 plus 2 lambda, minus 1 minus 3 lambda, minus 10 plus 8 lambda. Correct? So if in space, if what is position vector? Position vector is simply, if this point is 2, 3, 5, then the position vector of that point will be 2i plus 3j plus 5k, like that. Okay. So here also the position vector of any general point means like that, means general coordinates of any point on this line is like that. Okay. We will use this in the future. Okay. Problems. Okay. This is how you write the general point on this slide. Okay. So further we'll solve this question after seeing some more questions in between. Okay. Now coming to the next one. Next concept. Internal angular bisector and external angular bisector. Okay. So quickly I want to give a thing. If I draw a parallelogram like this, then in this parallelogram, you will have two diagonals. One diagonal like this. So you all know what do I mean. Like if this is A bar, very common figure, B bar, then the green color vector, what will it be? It will be A bar plus B bar. Okay. Now, if I draw this vector, let's say something like this. Let's say if I draw, you will get another vector or not? Now, what will be this vector? It will be B bar minus A bar or A bar minus B bar. Okay. See, in this diagram, what you should understand is this one is origin. And since A bar is the position vector of point A, we write in bracket like this, A bar. Okay. And what is the position vector of point B? From origin, if you join B, which vector it is representing? B bar. So in bracket, we will write B bar. Okay. So this is C. From origin, which vector is pointing towards C? A bar plus B bar. So in bracket, we will write A bar plus B bar. Okay. So now if I want this vector, any vector, if you want a vector joining points A and B, what will you do? You will subtract the position vector of B bar final and initial, na? B bar minus A bar. Here also, this is that other diagonal. So final point position vector minus initial position vector. That should be the vector. So what is that vector? B bar minus A bar, final minus initial. Okay. Now if I ask you, in a parallelogram, does the diagonal, any diagonal you take, does the diagonal divide this angle into equal parts? Is alpha equals to beta? That is my question. So this diagonal is there. Will it divide into two equal angles, alpha, beta? The answer is no. Okay. Why? Because if this is beta, then this must be beta. Okay. Alternate interior angles. Now, if you just see this triangle, just you see, try to see only this triangle. This one, this one, this one. This is very important concept, guys. Many places this will come. Okay. Now, if you see this triangle, alpha and beta are opposite to these two sides. This is one side and this is one side. If these two sides are equal, then only those two angles will be equal. No? Correct? In a triangle, if two sides are equal, their opposite angles will be equal. If sides are not equal, then the opposite angles will not be equal. Simple. Okay. So in a I said parallelogram. In a parallelogram, adjacent side need not be equal. No? So if OA is not equals to AC, adjacent sides, then alpha will not be equals to beta. So if OA is equals to AC, then alpha will be equals to beta. Okay. Now, if I ask you a question now, does A bar plus B bar bisect the angle between A bar and B bar? That means A bar plus B bar, is it dividing the angle between A bar and B bar? No, not always. Only when mod A bar equals to mod B bar, that's all. Okay, that point you remember. Now, let us see. What they are asking, internal angular bisector between these two vectors. Let us say this vector is A bar and this vector is B bar. Okay, so these are the two vectors, A bar and B bar, different length. Na? Immediately from here we can see what is the length of this vector. 49 plus 32, 81. Length of this vector is 9. Okay, what is the length of this vector? 3. Okay, now what will be the length of A bar by 3? So what I will do is, this is A bar. Na? I will write A bar by 9 unit vector. It will be in the same direction, A cap, and unit vector B cap also I will write. Okay, in the direction of B bar. Now if I add A cap plus B cap, these two are same length. Na? So that resulting vector will now bisect what we have learned here. Does A bar plus B bar bisect the angle between A bar and B bar? No. When will it bisect? If these two vectors are of same length. Now here also, A cap, B cap are same length only. Na? Okay. Then A cap plus B cap should bisect the angle between A cap and B cap. And it is bisecting the angle between A cap and B cap means it is bisecting the angle between A bar and B bar. Like that. Okay. So what is the funda? What is the internal angular bisector of A bar and B bar? It is A cap plus B cap. Remember that, guys. Okay. That's all. Do A cap plus B cap, you will get that vector. And they are saying you have to adjust that length. Okay. If you want a vector, if this is A bar, if I want a vector of length exactly 5 units parallel to A bar, what will be that vector? 5 times A cap. If you want a vector of 7 units, length 7 units in the direction of A bar, then it will be 7 times A cap. Now we need a vector of length 5 root 6 in the direction of A cap plus B cap. So I hope you can understand what to do. Okay. Next, find the distance of the point. Okay. So there is a point whose position, again, like we have discussed earlier, na? Whenever you are writing something, a bracket, in bracket a bar you are writing, that means that is the position vector of that point A. Now here also, B in bracket like this, it is there. So what is the position vector of point B? And position vector, with position vector directly you can write the coordinates of the point. Okay, I'm writing it 1, 2, 3. Okay. Now what they are asking, find the distance of this point to the line which is passing through a point whose coordinates is 4, 2, 2 and parallel to the vector 2i plus 3j plus 6k. Okay. If a line is parallel to a vector, we will say direction ratios of that line are 2, 3, 6, that components of that vector only. Okay. Fine. What they are asking in this question, they are asking the perpendicular distance. Okay. This distance BM they are asking. Okay. Now, if I know AB, do you know the length AB? Distance formula only, na? What is the length AB? Root over 3 square plus 0 square plus 1 square. Root 10 only, na, that length. Okay. So this length is root 10. If I know the length of AM, okay, here AM length if I know, then I will get BM, Pythagoras theorem only. Now this is what I am asking, guys. What is AM? What is AM? AM is nothing but, actually you guys should understand the meaning of projection. What is meant by projection means projection of AB on a line L. We will not say on a line which is in a direction, in some direction D bar. Okay, what I am saying, projection of this line segment on a line whose direction is D bar. Okay, so whenever you have that one, what you do is you draw perpendicular from A, perpendicular from B. Then this length, whichever is there, na, that is called projection of AB in the direction of D bar. Okay, you all know the formula, na? Okay, so what is the, if this is vector like this, A bar, and the direction of this line, it is B bar, then this is the projection, na? Okay, so this projection length, let's say this is AB, the length AB will be equals to A bar dot B cap. Length means modulus you will keep. Projection, simply A bar dot B cap. And what is projection? Vector projection. Just now we have seen, na? If you know length of some vector, then that vector will be equals to length of that vector into unit vector in the direction. What is the length of this vector? A bar dot B cap into unit vector in the direction is B cap, like that. Okay, fine. Anyway, we are only interested in the length here, AM. So what will be AM? AM is simply, now I will write this vector. What is this vector? Minus 3i cap, 0j cap plus k cap. And we know this direction also, direction of the line. So projection of A bar in the direction of B bar. What is that projection? A bar dot B cap. Let us write down. What is A bar? Minus 3i plus k dot product with B. B cap means B bar by mod B, na? 2i plus 3j plus 6k. What is mod B? 4 plus 9 plus 36. So this is 13. So you will get it as 7. Okay. So if you do dot product, how much you will get? Minus 6. I think plus 6. How much it is? 0. What does it mean? AM equal to 0? It means already the line joining these two is perpendicular to the line. So if I join A and B, it is already perpendicular to the line. So that's why if you drop the perpendiculars from A and B onto the line, both are falling at the same place. That's why the distance of M from A will be how much? At 0. Okay. So already this is like this. So what they asked in the question, perpendicular distance from this point onto this line, that is AB only, na? Directly answer in this case. Okay. Yeah. We'll see some more questions which will clear whatever doubts you have in the projection. Okay. Yeah. See here. Okay. That is okay. That is not a tough question. Short resistance will come to that. Actually, I wanted to give one question on projection. No? Yeah. Let us see this one. Projection of AB on CD. What is it here? Simple AB bar dot CD cap. That's all. Okay. You can write what is AB bar. No? You know what is CD bar. So CD cap is nothing but AB bar dot CD bar by length CD. Okay. Do that, you will get the answer. Some more questions on projection are there, one or two. I just want to show it first. Okay. Yeah. Here you see A bar, B bar, two vectors. Okay. So one vector is B bar, which is 5i minus 3j plus k. Now another vector is A bar, which is 2i plus j plus 2k. Now what are they asking in this question? Orthogonal projection of A bar on B bar. What is meant by orthogonal projection? You know what is normal projection, na? Just now we have seen. So what is the normal projection? This vectors. And that vector is, green color vector is A bar dot B cap. That is a projection into B cap. Okay. Now this I am saying A bar projection, you are doing A bar on B bar. No? That remaining vector, this one, violet one, that is only the orthogonal projection. So if you just follow the triangle rule, it is A bar minus A bar dot B cap into B cap. That's all. Okay. Do that one, you will get it. Next. One more question is there on that one. Okay. Yeah. See. Now this is very important statement, guys. What is that statement which I am seeing is they have given some three vectors. Okay. They are saying vector V bar in the plane of A bar and B bar. Okay. So V bar is in the plane of A bar and B bar. How will you take general vector which is in the plane of A bar and B bar? Now, actually, you should take lambda A bar plus mu B bar. Whenever you do linear combination of two vectors in a plane, two vectors will be always in a plane. So let's say on your whatever screen you are watching, let's say two vectors are there. If you do any linear combination, that is 5A bar plus 7B bar, if I do, that will also be in that screen only. It won't come outside the screen. Okay, it will be in the plane. Okay. So if they say whenever you see this statement, this is very common statement, a vector in the plane of A bar and B bar, immediately you can take like this, or sometimes you can take A bar plus lambda times B bar. Anyone you can choose. Okay. But actually this is more preferable, general one, constant for both. Okay. Yeah. So what is the question? Again, this is previous JE question. Okay. A vector V bar in the plane of A bar and B bar, whose projection on C bar. What is the projection here formula? The projection of V bar on C bar is given by V bar dot C cap. And that they are saying 1 by root 3. That is V bar dot C bar by mod C bar is 1 by root 3. Mod C bar is 1 root 3 only, you can see from here. These two will get cancelled. So they are saying V bar dot C bar must be 1. Okay, let us write down. What is V bar? Lambda A bar plus mu times B bar. Dot C bar must be 1. So lambda times A bar dot C bar plus mu times B bar dot C bar must be 1. So put what is A bar dot C bar? If you calculate 1 minus 1 minus 1 minus 1 minus lambda plus what is B bar dot C bar? 1 plus 1 minus 1, 1 plus mu is equals to 1. So mu is equals to 1 plus lambda. Okay. Let us substitute that here. Okay. I'm telling you, this is previous JA question. Na? Everything looks easy. Now you see, finally answer we have to mark. Na? Little complicated it will become. Lambda A bar plus what is mu? 1 plus lambda times B bar. So what do we get? We'll get B bar plus lambda times A bar plus B bar. Now just do what is A bar plus B bar. What is A bar? So what is B bar? We already know. What is B bar here? It is I minus J plus K plus lambda times, what is A bar plus B bar? If you add them both, you will get 2 times I plus K. 2 times means that 2 you can mix in lambda. Okay. So finally you will get 1 plus lambda I minus J cap plus 1 plus lambda times K cap. There is no one definite answer for this. Any vector which is of this form will be in the plane of A bar and B bar, and its projection on C bar will be 1 by root 3. Okay. Now you need to see which vectors are of that form. The observation is X component and Z component must be same, and Y component must be minus 1. You see which vectors have like that? Only option C. Na? That's all. Okay. Yeah. Now we'll come to next question. Yeah. Shortest distance between two lines. Okay. So already you know, just I'm writing the formula. If two lines are given, R bar is equals to A bar plus lambda B bar. Another one is R bar equals to C bar plus lambda times D bar, let's say. What does it mean? First, understand it like this, it will be easy. First line, what is the direction of first line? B bar. What is the point on the first line? A bar. Visually, I am showing you. I will write the formula now. Okay. What is the point on the second line? C bar. What is the direction of the second line? D bar. Now, when it comes to formula, the shortest distance is simply determinant of, okay. You know what is det, na? Det. Det will have 3 rows now. Okay. What are those 3 rows? First row will be simply this vector, A bar minus C bar. Now you may say, sir, determinant means how is it a vector? In determinants, we write numbers, na? Like 1, 2, 3. Now these 3 are nothing but X, Y, and Z components of that vector. Okay. Fine. So instead of writing everything, I'm just writing that vector. Okay. Now next row must be first one direction, and next row must be another direction, D bar. Okay. But I will tell you, there is much, actually you should be able to do much faster if you calculate the denominator first. What is denominator? Is modulus of B bar cross D bar. Okay. Now to calculate the denominator, you need to calculate B bar cross D bar. Yes or not? Now after that, numerator will be simply A bar minus C bar. You do dot product with B bar cross D bar. That's all. What is A bar minus C bar? Subtraction of 2 points, na, on these lines. Any 2 random points. B bar cross D bar, you will calculate from the denominator, na, anyway. Okay. So once you calculate this, you do the dot product. Let us do for this question as fast as possible. Okay. I'm doing it trying to do it little fast. This is B bar, this is D bar. So what is B bar cross D bar? That will be det I, J, K, 1, 2 minus 3, 2, 4 minus 5. So if I do that, I'll get I times minus 10 plus 12, 2 minus J times minus 5 plus 6, 1 plus K times 4 minus 4, 0. So 2I minus J is B cross D. So in my shortest distance, denominator is already taken care of, root 5, na, it is. Numerator is A bar minus C bar I have to do. So subtract these two. It will be 3I. J will get cancelled, minus 2K. This you need to do dot product with this vector. If you do dot product, you'll get 6. That's all. 6. K and J are there. 6. That's all. This will be the shortest distance between these two lines. Okay. Fine. Next. You would have seen something like this. Okay. So, okay, fine. I'll do one thing. I'll cover the other aspects, because box product is very less weightage normally if you compare previous years and all. Let us concentrate on which are more probable of coming in the exam. Okay. Yeah. Linear dependent. These questions are coming very often. Okay. Now in linear dependent independent concepts, there are actually three categories. One is two vectors linearly dependent. When will be two vectors linearly dependent? If they are collinear. Already we have seen what is the definition of collinearity. A bar equals to lambda times B bar. Then two vectors will be what here? Linearly. So even in the question, if they say the two vectors are linearly dependent, it is same as saying, exactly same as saying the two vectors are collinear. When it comes to three vectors, if someone is saying three vectors are linearly dependent, it is exactly same, congruent statement. Okay, two triangles are congruent means exactly same. Na? Just one triangle can be rotated and kept, but they mean the same. They are same triangles. Here also these two are. If three vectors are linearly dependent, if they are saying, that means those three vectors are coplanar. Both are the same statement only. There is absolutely no difference, no exceptions. Okay, simple. Three vectors are coplanar. So four vectors are linearly dependent. If someone is saying four vectors are linearly dependent, it is almost same as saying two points are always, if I tell you that 2 points are always collinear, it is an obvious statement. No? 2 points will be always collinear. Or if I say you 3 points are always coplanar, obvious. You select any 3 points, always they will be in one plane only. No? You will get a triangle. The triangle is that plane. If you extend it, you will get a plane like this. Okay. Don't you think these are obvious statements? Now, even the last one also, it is obvious statement. And in questions, you won't get any obvious statement. Find lambda such that 2 points are collinear. You will not see questions like that. No? So obviously, you're not going to see a question where they will say four vectors are dependent. Find it is always true. Okay. So we don't have any applications for that one, like any equivalent. Mainly these two is something which you need to concentrate. Okay. Now, when two vectors are dependent, we have seen what is the condition. If two vectors are dependent, if one vector is a1 I cap plus a2 j cap plus a3 k cap, another vector is b1 I cap plus b2 j cap plus b3 k cap. If these two vectors are dependent, then a1 by a2 equals to b, sorry, not a1 by a2. a1 by b1 must be equals to a2 by b2 equals to a3 by b3. Like that you will write. Na? Same way, if three vectors are linearly dependent, that means, let me just, three vectors when they are saying. No? So when three vectors are linearly dependent, one more vector is c1i plus c2j plus c3k. Then det of a1, a2, a3, b1, b2, b3, c1, c2, c3 must be 0. Or if three vectors are coplanar, this is the condition. Okay. Sometimes they may say 4 points are coplanar. See, 3 points are always coplanar. Okay. If 4 points are coplanar, that means these three vectors will be coplanar. Correct? So whenever they give 4 points, if they say they must be coplanar, then you can write these three vectors, na? BA, BC, BD. Then those three vectors, det must be 0. That's all. Okay. So in this question also, you see, these three vectors are linearly dependent, they are saying. That means det of that must be 0. Okay. Fine. Let us go to the next part. Yeah. Tetrahedron. You know about tetrahedron, no? So tetrahedron is nothing but you take a point in a space, connect it to a vertices of the triangle, you will get a tetrahedron. Okay. Now you know what will be the volume of this tetrahedron. So for finding volume of the tetrahedron, you need to have three vectors. The three vectors must originate from the same vertex and end at the opposite face vertices. If you know these three vectors, then the volume of tetrahedron is box A bar, B bar, C bar by 6, which is same as writing det. First row is A bar, second row B bar, third row C bar by 6. Okay. Now, what will be the height of this tetrahedron? For example, from D, if I want the height of this tetrahedron, okay, what will be its height? Okay, let us see. Height of, so first we need to understand before going for height, if you have a triangle, if you know its area, then what will be the height of this triangle? With base you can find, no? Area is half into base into height. So height will be nothing but 2a by b. Okay. Same way, whenever you have a figure which is random shape, for example, okay, let us take easily circle. Circle, if you join with a point, what do you get? You will get a cone. No? Okay. The volume of all such figures, there is a general formula, that is 1/3 of base area into height. In areas there is half, na? In volume it is 1/3. That factor is. You would have wondered sometime why why this half would have come in area. Na? Same way, okay, if you have accepted it, accept this also. For volume 1/3 will come similarly. Okay. Now here also for this tetrahedron, the volume will be what here? Half into base area. Okay, so area of triangle ABC into height. So if you need height, the answer is 2 times volume by area of triangle ABC. Okay, you know how to find volume? Yes or not? This is the formula. Then area of the base triangle. How will you find area of any triangle? If you know two sides of the triangle, you can do the cross product. No? Then the cross product only will give you the area, half of those two vectors cross product. Okay. Next. One second, guys. Yeah, one important question is there. This, I think, you need to spend. I will solve this question, but you need to take a screenshot. Okay, very important question. I think this model in JEE advanced itself, they have repeated. I think 2-3 times it has come. In JEE mains also it has come till now 2-3 times. Okay. Definitely one in 2014 it has come, and also recently 2017 and also 2020 also. Okay. See, the point is like this. To solve this question, you should know what is vector triple product. Okay. Let me write down A bar cross B bar cross C bar. So what is the formula here? Outer dot product. First A bar dot C bar into inner vector B bar minus next inner dot product A bar dot B bar and whatever is remaining, that is C bar. Okay. If you have A bar cross, same funda, A bar cross B bar cross C bar is there. First outer dot product. What is the outer dot product? A bar dot C bar into inside vector, that is B bar, minus inner dot product, that is B bar dot C bar into the remaining vector, that is A bar. That's all. Okay. You see, both are not same. They both are different. Fine. Okay. Now coming to this one. A bar cross B bar plus C bar is 0. And they give A bar dot B bar, which is how much? 3. Then they are asking to find the vector B bar. Okay. Now you see they have given A bar and C bar. Okay. Now what you do is here, this equation. See, A bar C bar is given. So unless you know B bar, you can't do this cross product. Okay. But you have to find B bar. No? Okay. So you need to get rid of this cross product. And you see, whenever on the left side, there are a lot of cross products in this formula. But on the right hand side, there is no cross product. So whenever you have to get rid of cross products, what you will do? You will do one more cross. Okay. Now in this case, we will do cross product with A bar everywhere on the right side as well as left side. That means I'm doing cross product with A bar cross A bar on the left side. Right side also A bar cross 0 bar, which is 0 only. So this, if you multiply it inside, A bar cross B bar plus A bar cross C bar equals to 0. Now this one, outer dot, na first. What is outer dot? A bar dot B bar. Already they gave A bar dot B bar, that is 3. Okay. So this will be, outer dot will be 3. What is remaining vector? A bar. Minus inner dot. Inner dot is A bar dot A bar. What is A bar dot A bar? Mod A whole square. What is mod A? Root 2. Mod A whole square is 2. 2 times remaining vector B bar plus A bar cross C bar equals to 0. So what will be B bar? 3 times A bar plus A bar cross C bar divided by 2. Now, do you know A bar? Yes. Do you know C bar? Yes. They have given in the question. A bar and C bar. So if you know both of them, then I think you can find B bar. No? Okay. This question you take a screenshot. Okay. Next. Okay. Those who are already familiar with this box product, na, let me just give you a quick formula. Okay. So because I can't explain the box product again, that much time is not there. Okay. If you know already what is meant by box of A bar, B bar, C bar, I would like to give a formula. This is nothing but A bar dot B bar cross C bar, or you can also write it as A bar cross B bar dot C bar. Okay. Anything you can write. The cross product of first, second into dot with third, or you do cross product of second and third and do dot with first one. Okay. And you can always rotate them, the order in which they are there. That only matters. That is A, B, C. If I write like this, B bar, C bar, A bar. Now, if you start with A and like this, if you go A bar, next B bar, next C bar, it's the same order, na? So these two will be same. For example, if I say B bar, A bar, C bar, if you go like this, then go right and then start from the beginning. A bar, C bar, B bar. The order is not A, B, C, na? So it will be not same. Okay. To make them same, if you want to bring it to same order, then you have to put a minus sign. A bar, B bar, C bar. Okay. That is one rule, first rule. But that is not what I want to say. Okay. This is the basic rule. Now, for example, if you see this, whatever they have given, there are 1, 2, and 3. These are the 3 vectors or not? So can I say that is box of 2A bar minus B bar, A bar cross B bar, and A bar plus 2B bar, like that. Okay. And if you need box product, then you just need to write the vectors in each row. Okay. So first row will be 2A bar minus B bar, second row A bar cross B bar, third row A bar plus 2B bar. Now the rule which I want to say is, whenever you have box of some x1 A bar plus y1 B bar plus z1 C bar, x2 A bar plus y2 B bar plus z2 C bar, x3 A bar plus y3 B bar plus z3 C bar. This box product will be equals to det of x1 y1 z1, x2 y2 z2. Directly you can apply this formula, x3 y3 z3 times box A bar B bar C bar. That's all. Okay. So for example, in the question, if someone it is saying that box of A bar B bar C bar is equals to 10, then box of 3A bar minus 5B bar plus C bar, 2A bar minus C bar, 5B bar plus 7C bar is equals to how much? Now, all of them are linear combinations only. So those linear combinations, you write it like a determinant. In the first one, 3 minus 5, 1 are used. Na? In the second one, 2, 0, minus 1. There is no B bar, na? So 0 I am writing for that. In the third one, 5, 7, 0 for A. This times box A bar, B bar, C bar. Now you can evaluate this determinant. Already you know this value, that is 10. You'll get the answer. Okay. Let's proceed. Next. Coming to the plane. So already, I hope you are familiar with this one, plane. Okay. So previously we have seen, for example, if some point is given, okay, let's say 1, -1, 2. If a line is given, okay, so in vector form we have seen the line. Okay, in Cartesian form means it is passing through -1, 1, 1, let's say, and it is parallel to a vector which is I minus j plus k. But in 3D geometry, what you'll use? Direction ratios. If a line is parallel to 1 minus 1k, the direction ratios will be 1 minus 1, 1. Okay. Then what will be the equation of the line? General line, x minus x1 by a equals to y minus y1 by b is equals to z minus z1 by c. A, B, C are direction. So if I just write x plus 1 by 1, y minus 1, y minus y1. This I have to use, na, by b. What is the y component of direction ratio? -1. Z minus z1, 1 by z component of direction ratio, 1. Okay. Now, if I ask you what is the general point on this line, how will you write? So if you want a general point on this line, you equate it to lambda, each one of them. So x you will get it as lambda minus 1, y you will get it as minus lambda plus 1, z you will get it as lambda plus 1. So what is the general point on this line? Lambda minus 1, minus lambda plus 1, and lambda plus 1. So in vector equation of line, you would have seen lambda, na? A bar plus lambda b bar. Whatever is the role of that lambda, same role, if you equate it to lambda, you will get. Okay, it's the same. Now, for example, if you need foot of perpendicular, because actually it is a very common question, but I didn't discuss that one, foot of perpendicular. I just discussed perpendicular distance. Okay. I'll just revise you how to find the perpendicular distance. See, AB is there. If you know length of AB, if the foot of perpendicular is M, AB you know length already because you know the points A and B. Okay. Do you know the direction of AM? Yes, we know. Why? Because already they have given us the direction of the line. Okay. So even if they give the line like this, you can write the direction of the line. Na? These three X, Y, and Z components, you can write the direction. We know the direction. Can you find the length AM? Yes. AM is nothing but if the direction of the line is B bar and this vector is A bar, then AM length will be nothing but A bar dot B cap. You can find, no? Projection, that only, no? The funda of projection. A bar dot B cap. That means you know the length of AM. So we are just finding the lengths. AB we know, AM we know. Then you can find BM, Pythagoras theorem. If you try to practice some problems like this, then you'll get faster. Without practice, no. Okay. Now the question is, let's say you want foot of perpendicular. Then how to find the foot of perpendicular from point B onto this line? Simple. Already you have written the general point, no? So simply what you do is, if this point is point M, then the angle between BM and the line must be 90 degrees. You know what is BM vector? Subtract. You know what is the line vectors? That is this one. Dot product you equate, you will get the value of lambda. That lambda, if you substitute here, you will get the point P. That means the point P, if you, okay, sir, lambda, if I substitute 10, what I will get? You may get any point on the line. Okay. But when you are finding lambda with this, if you substitute that value of lambda, you will get point M. That is foot of perpendicular. Okay. That only I wanted to just discuss before going ahead. Now, Coming to this question, the ratio in which the plane in 2D you have learned, no? If you have a line 2x minus y minus 1 equal to 0. Let's say if I have 2 points, one point is minus 1 comma 2. Another point, let's say B is 2 comma 5. Now these 2 points will be on the same side or opposite side. You will substitute the point in the left hand side, that line expression. If I substitute minus 1, 2, I will get minus 2, minus 1, negative. If I substitute 2 comma 5, I will get 4 minus 5 minus 1, negative. Both are same sign, so both will be on the same side. Okay, so 2 comma 5, this is correct figure. Okay, now if I extend like this, that this if you extend, it will intersect at some point, this AB. If they ask you in what ratio line divides line joining A and B, that means they are asking PA by PB. Simply what you will do is L of A minus of L of A by L of B. That will be the answer. Okay. So P divides A and B externally. Na? What is that ratio they are asking? Direct formula is, what is L of A means, this is the line expression na, when you bring all constants one side. Okay. So minus of, substitute the point A in that expression. Already we have substituted, we'll get minus, how much here? Minus 5. Divided by, substitute the point B in the expression. Already we have substituted. How much you will get? Minus 2. You will get the answer minus 5 by 2. Correct? So that since P is outside, negative means external division, na? Like that. So in what ratio the line will divide A and B? In the ratio 5:2 externally, because negative you are getting. Okay. Same way, if you bring in 3D also, when you have a plane in 3D, okay, if you are joining 2 points, let's say points are opposite side, then it will intersect at some point on the plane, this line joining the points. If they're on the same side, you will extend, just like what we have done before. Okay. In what ratio this plane, for example, in this case, the plane equation, everything, write it like an expression, bring everything one side, 2y plus 3z minus 17. Let's call this as plane we represented by pi. Na? So in what ratio, or let's say in the question only, in what ratio the plane divides line joining these 2 points? So the answer is minus of pi of A by pi of B. Okay. Substitute the point A, substitute point B in the plane expression, not here. If you bring everything one side, you will get one expression. Na? That left hand side you have to substitute and divide. That is the answer. Okay. Yeah. Next, all these are basic questions. I hope you can do it yourself. Okay. This also, this line we have seen just now. Okay. So whenever 2 lines are perpendicular, that means if 2 lines are perpendicular, the vectors which are parallel to them must be perpendicular. How to write vectors parallel to them? What I told, these are the components of the vectors parallel to them. Na? And you need to make sure, for example, if the question is, assume that this is not given. I am writing one first line. Okay. Observe this very carefully. 1 minus x by minus 3 equals to 2y minus 4 by 1 equals to z plus 2 by minus 2. For example, like this it is given. This line and this line, red color one, these two are perpendicular. Okay. That means the vectors which are parallel to them must be perpendicular. Already we discussed. Okay. Now think about what is the direction of the red color line. Okay. So let me use the color also same. Okay. One is red color line. Other one is blue color line. Okay. You know which one is red, which one is blue. No? The one circled with red pen is red color line. Okay. Now, what I need to do, I need to write vectors which are parallel to them. Okay. First one, 3k I cap plus j cap. Z component is minus 5 times k cap. Second one, x component, y component, z component. If I write like that, okay, that is minus 3 I cap plus j cap minus 2 times k cap, then it is wrong. Okay. Because before writing the direction, the main thing which you need to take care is the line in the standard form. Whenever a line is in standard form, this is a line in the standard form. The coefficient of x, y, and z in the numerator must be 1. The coefficients must be 1. Then only we say the line is in standard form. Here, is it 1? No. To make it 1, what I should do? I should take minus common or not? X minus 1 by that minus, if it goes to denominator, 3. Here I should take 2 common or not? Y minus 2 by 1 by 2. That 2 if it goes to denominator. Here it is okay. Now you should write, what is the direction of the second line? 3I cap plus 1 by 2 times j cap minus 2 times k cap. That's all. Now the dot product of these two must be 0. Okay. Yeah. Next. So direction, how to identify, we have seen, na? Okay. The bottom components. Now, if I ask you, tell me a point on the blue color line. One point you tell me. If I ask you, okay. Then immediately what you need to do, I'll tell you. Okay. You equate it to 0, for example. What do we get x? 1. What do we get y? 2. What do we get z? Minus 2. What is one point on red color line? You equate it to 0. What do we get x? 1. What do we get y? 5. What do we get z? 6. If I ask you what is the general point on red color line, you equate it to lambda. That's all. Already we have seen. No? 3k lambda plus 1, lambda plus 5, minus 5 lambda plus 6, like that. General point you will get it. Okay. So now coming to this one. 2 lines they have given. They are saying coplanar. When 2 lines are coplanar, they will definitely intersect. Imagine on your table, you are drawing 2 lines, non-parallel lines. Okay. They should intersect. No? But in the space, if 2 lines are there, they need not intersect. So just like for Sankranti or Pongal, you are flying 2 kites. Let's say the thread is that line only. Now they need not intersect. No? Yes or no? So because it is in space. Now, so whenever if I am saying 2 lines are intersecting, again here also equivalent statements we said na previously, just like congruent triangles. If I say 2 lines are intersecting, or if I say 2 lines are coplanar, or if I say the shortest distance between 2 lines is 0, all these 3 statements are same. Okay. So here they are saying they are coplanar. Done. So that means the shortest distance must be 0. That means shortest distance, what is the numerator? That must be 0. In the numerator, what is there? If you take 1 point on one line, okay, here what is 1 point on first line? 2, 3, 4. What is the direction of first line? I plus j minus k times k cap. Okay, minus k is there, no component. What the other line? What is the point on the other line? 1, 4, 5. What is the direction of the second line? K I cap plus 2 j cap plus k cap. What you should do? Numerator, subtract the point. These 2 points. Okay. You'll get 1. You'll get a vector, na? That components directly you write down. Minus 1, minus 1. Then write these 2 directions. First one direction, 1, 1 minus k. Second one direction, k 2, 1. This det must be 0. Denominator something will be there. So that will go right side. No? So you'll get k. No? Okay. Very commonly asked question. 2 lines coplanar means shortest distance 0 you have to do. Okay. Next. This we have seen. No? Length of perpendicular from this point onto this line. Projection. Let me do this question for you. Okay, you also try parallelly. You see calculation, everything included. I'll just see how much time it will take. Okay, you may have another techniques also, na? If it is faster, then let me know. Okay, I don't mind learning from student. Okay, let us see what they are saying. Length of perpendicular from 3 minus 1 11 onto this line. So 0 2 3, and the direction is 2i plus 3j plus 4k. Immediately draw this vector, that is 3i plus 3j plus 8k. Now projection of this vector on this vector, that is this dot, that cap. So do dot product for 6 plus 9 plus 8 for the 32. Divided by root this one 4 9 16. If you add them, how much you will get? 25 29. Okay, so overall it will be how much here? 15 means 47 by root 29. So this length will be 49 by root 20. Sorry, 47 by root 29. It should not give such large values, no? I think I made some calculation mistake. 3, acha, this is minus 3j, na? 11 minus 3, 11, yeah. So dot product when you do, minus 9 here it will be. Okay. So 32 means 29. So it will be root 29, this one. Okay. Now what is this length? 9 plus 9 plus 64. So 64 plus 18, no? Or 20. 84 minus 2, 82. Root 82. So this length will be Pythagoras theorem. Root over 82 minus 29. Root 53. Okay. I have kept the stopwatch. It was 1 minute 30 seconds something. Okay. I made some error, na? Otherwise it would have been faster. You can always follow this method. Okay. And it will give more idea about the projection also. Because projection commonly, questions are coming in one shift or other every year. Okay. Vector projection. This is orthogonal projection. Okay. Fine. So I hope one thing we didn't touch today was, if you have a point and a plane, from point and line we have seen perpendicular distance. Okay, how to find the foot of perpendicular. You search in Google, or it is just a formula only. Okay, if you know a point and a plane equation, you know, then the perpendicular distance formula will be there, and there will be formula for how to find the foot of perpendicular, and also there will be formula how to find the image of that point. Okay, remember those formulas, very important, guys. Fine. Yeah, whatever I could cover in 1 hour, I have covered here. Okay, vector 3D. Remaining we have to revise. Fine. Okay, do what do you call? Everyone do the previous JEE mains question without fail on vectors and 3D. Okay, on the same day itself, today itself. Okay, guys. Fine.